In this video, we are going to go over how to simplify logarithms when we're using all three properties. In previous videos, we have tackled these individually. You're not always going to have problems that only have one property and you're done. You're going to have to be able to use all three of them. So let's look at an example. Here we have 20 times the log base 7 of 11 minus 4 times the log base 7 of 6. So this first part that we should notice is that 20 being multiplied by the log and that 4 being multiplied by a log. So that implies our power property. So if we go back to that first slide, that's our power property, where we have some number n times the log base b of m. We can rewrite that as an exponent. So we can simply move that 20 up into a power of the 11. So this first one simplifies to a log base 7 of 11, and the 20 becomes your exponent on that 11. Same thing happens on this other part. That 4 is going to become an exponent on that 6. So we have log base 7 of 6 raised to the 4th. Now, the next property that we have two logs being subtracted. So that is our quotient property. We can rewrite that as one log, base 7, of the first guy. So let's go this first guy right here, over the top of our second guy. This guy right here. So we have 11 raised to the 20th over the 6 raised to the 4th. And this would be our final answer. Let's look at another example. Here we have log base 4 of 5 plus log base 4 of 3 plus 5 times the log base 4 of 8. So first thing we're going to deal with, we have the power property right here. So we're going to deal with that guy first. I'm going to go ahead and copy down the first two that I have not worked with yet. And I'm going to move that 5 out front to an exponent on the 8. So we have log base 4 of 8 raised to the 5th. Now we have three things being combined with addition. We can use our product property to combine the first two. So this becomes log base 4 of 5 times the 3. And we have another log base 4 being added to it, so that's another times the 8 raised to the 5th. 5 times 3 we can work with, so this becomes a log base 4 of 15 times 8 to the 5th, and this would be our final answer. Let's look at another example. Here again we have three logs being added together. That's going to be the product property. And on this last guy right here, we have a power property with that 4 in front of the log. So we can go ahead and combine these first two if we want. That becomes a log base 7 of the 11 times the 6. And over here we have our plus the log base 7 of 5 raised to the 4th. We have the plus the two logs being added together, so now we can go ahead and move that. Log base 7 of our 11 times the 6 times that 5 to the 4th. 11 times 6 we can work with, so we can simplify one more time to a 66 times that 5 to the 4th. And that would be our final answer. Let's look at a fourth example. Here it looks a little bit more complicated because we're dealing with fractions. But are the fractions really any different? They're still just a power property. We can rewrite a divide by 2 as a multiply by 1/2. So let's look at it that way. Log base 9 of 11 plus a 1/2 times the log base 9 of 12 plus a 1/2 times the log base 9 of 5. Now those second two, the second and third log that we have there, is a power property. We can move that 1/2 up to be an exponent. So we have a log base 9 of 11 plus a log base 9 of a 12 raised to the 1/2 plus a log base 9 of a 5 raised to the 1/2. So now we can go ahead and combine. They're all plus, so we can use our product property. We have a log base 9 of an 11 times a 12 raised to the 1/2 times a 5 raised to the 1/2. And we would have a final answer right here. Let's look at a fifth example. Here we have a 4 times the log base 8 of 2. That's a power property. Then we are subtracting a 12 times the log base 8 of 5. There's another power property, and that minus sign in between is a quotient. So deal with one at a time. Here we have a log base 8 of 2 raised to the 4th minus a log base 8 of 5 raised to the 12th. Now we can use the quotient with that minus to write this as a single log. So log base 8 of the 2 to the 4th over the 5 raised to the 12th. And here is our final answer. Let's look at another example. Here we have a 2 times log base 5 of w plus a log base 5 of u all over 2. We have some variables in here now, but it's not going to change the process any. First, we have a power property. We can rewrite this guy as a log base 5 of w squared plus divide by 2 is the same as multiplying by a 1/2. So that becomes a log base 5 of u raised to the 1/2. We're combined with addition, so that's our product property. We can combine these two logs into a single log base 5 of w squared times u to the 1/2. You could also write that u to the 1/2 as a square root. Either answer would be an acceptable answer for me. So w squared times the square root of u. Either of those would be an acceptable answer. Let's look at another example. Here we have 10 times the log base 4 of x minus 5 times the log base 4 of y. So we have the power property and we have the quotient property. So let's take care of the power first. We have a log base 4 of x raised to the 10th minus the log base 4 of a y raised to the 5th. Now we can combine these two logs with the quotient property into a single log base 4 of x to the 10th divided by y to the 5th. And this would be our final answer. Let's look at one last example. Here we have a log base 2 of z plus a log base 2 of x all over 3 plus a log base 2 of y all over 3. That dividing by 3 is the same as multiplying by a 1/3. So we can use the the power property on those, and then the two addition signs there, we would use the product property. So we leave the first guy there, log base 2 of z, plus move that 1/3 to an exponent, log base 2 of x raised to the 1/3. And on that last guy, move that 1/3 as well. So you'd have a log base 2 of y to the 1/3. Now all three of these are combined using the product property, so we can combine them into a single log base 2 of a z times an x to the 1/3 times or y to the 1/3. We could leave it there, or we can notice that both of those are 1/3. So we could also write this as a log base 2 of a z, and then a cube root of our x, y. Either one would be an acceptable answer. So now you have the ability to start working with more than one property at a time. The individual steps are not any different than what we did before. You just have to repeat the process again. You deal with one property, simplify, and look to see if there's another property that you can work with.